If you have ever observed rusted iron, tarnished silver, or the green patina that develops on copper or bronze, then you are familiar with corrosion. Corrosion is the term used to describe the process of the surface of metal objects getting covered by oxides or other salts of the metal. In corrosion, the metal is oxidized by losing electrons to oxygen, forming oxides. Corrosion is essentially an electrochemical process. Let's look at the corrosion of iron, which is commonly known as rusting, in detail. Iron corrodes in the presence of water and air. The spot where the corrosion begins can be considered the anode. Here, iron loses 2 electrons to form the iron 2 ion. The oxidation half reaction has an oxidation potential of minus 0.44 volt. The electrons thus released then move to another spot on the metal, which then behaves as the cathode. At this spot, oxygen is reduced in the presence of a hydrogen ion to form water. The hydrogen ions are believed to be available either from carbonic acid that is formed when carbon dioxide dissolves in water, or due to the dissolution of other acidic oxides from the atmosphere. The reduction potential for this process is 1.23 volts. In the overall equation, iron is oxidized to iron 2 ions, while oxygen is reduced to form water. The cell potential is 1.67 volts, consistent with a spontaneous reaction. The ferrous ions formed are then further oxidized by atmospheric oxygen to ferric ions in the form of hydrated iron 3 oxide, commonly known as rust. It is very important to prevent corrosion because it damages electrical towers, bridges, buildings, which can collapse as a result, and ships, which can develop a breach. Corrosion can also force major industrial plants, such as power plants or chemical processing plants, to be shut down. Hence, corrosion not only results in loss of money, but also endangers public safety. How can corrosion be prevented? One way is to cover the surface with paint or some chemicals like bisphenol. This creates a physical barrier that protects the metal. A second alternative is to cover the surface with other metals, such as tin or zinc. Like paint, this prevents oxygen and water from reaching the metal surface. We can also use electrochemistry to prevent corrosion. In cathodic protection, the metal is coated with another metal that is more easily oxidized. In cathodic protection of iron, iron becomes the cathode and the metal coating becomes the sacrificial anode. Cathodic protection can be used to protect steel pipes from corrosion. Magnesium oxidizes more readily than iron, as you know from the table of standard reduction potentials. In this diagram, a magnesium rod is buried and soldered to a steel pipe. Magnesium acts as the anode and the pipe acts as the cathode. The damp soil acts as an electrolyte. The magnesium rod can be dug up and replaced. This is much faster and less expensive than replacing the pipe itself. Try to answer this question on your own before proceeding. Based on the table of standard reduction potentials, which of these metals could provide cathodic protection to iron? Aluminium, copper, nickel, or zinc? Answer: aluminium and zinc could be used to protect iron from corrosion. As shown in the table, their reduction potentials are more negative than that of iron. This means that they are more readily oxidized than iron. Copper and nickel reduce more readily than iron, making them unsuitable for cathodic protection.